The resistance of a given wire using Ohm's law. Understanding resistance. Ohm's law. Hey NEET aspirants. Today, we're diving into the fascinating world of electricity, specifically focusing on the resistance of a wire using Ohm's law. Let's get started. Scene 1. Visual of a simple circuit with a battery, wire, and resistor. Narrator. First things first, what is resistance? Resistance is a measure of how much a material opposes the flow of electric current. It's denoted by the symbol R and is measured in ohms, omega. According to Ohm's law, the relationship between voltage, V, current, I, and resistance, R, is given by the equation V equals IR. This means that the voltage across a conductor is directly proportional to the current flowing through it. But what affects the resistance of a wire? There are several factors. Length of the wire, L. The longer the wire, the greater the resistance. This is because electrons collide with more atoms as they travel. Cross-sectional area, A. A thicker wire has a lower resistance. More area allows more electrons to flow. Material of the wire. Different materials have different resistivities. For instance, copper has low resistance, making it a good conductor. The resistance of a wire can be calculated using the formula R equals ρ, LA, where ρ is the resistivity of the material, L is the length, and A is the cross-sectional area. To recap, remember, resistance is influenced by length, area, and material. Ohm's law helps us understand the relationship between voltage, current, and resistance. Use R equals ρ, LA, for calculations. Scene 6. Closing shot with a call to action. Narrator. Now that you understand the basics of resistance using Ohm's law, you're one step closer to mastering your NEET syllabus. Don't forget to like, share, and subscribe for more educational content. Keep studying, and good luck with your preparation. Ending scene, music fades out, screen shows, thanks for watching.